Hi, everyone. I'm Erfan, second year PhD student at University of Washington, and today I'm here to explain my work as an intern at EarthScope with the title of Characterizing Natural and Anthropogenic Signals Using Dual DAS Interrogators at the EarthScope Primary Instrument Center in the Socorro, New Mexico. Okay, in the first step, I want to say how the DAS, distributed acoustic sensing DAS works and what it is. And okay, let me show a video about that. In this technology, we use optic fiber cable as the array of the sensors. So we have an interrogator at the beginning of the cables, which sends pulses through the cable and receive the backscattered signals. And it calculates the phase differences for each point of the cable. So in this way, we can calculate the strain and convert the phase difference to the strain and calculate the strain for each part of the cable and figure out the effect of the external sources and external forces on each part of the cable. So we can convert optic fiber cable to the array of the sensors, and it gives us 2D data, which one dimension shows the channels, and each channel creates us a time series like other seismic instruments. In the EarthScope, we have DAS instrument deployed in the New Mexico Socorro. We have a cable with the 1 kilometer length at FEPIC. And also we deployed two interrogators, Scintilla and Phoebus, and and there are two fibers for each interrogator. And the sampling rate is 40 kilohertz, which is decimated to the 1 kilohertz for better handling the data. And also the channel spacing and the gauge length varies case by case. In this internship, my goal was first developing pipelines for loading, reading, filtering, analyzing, and visualizing the DAS data. And also after that, I went through investigating different events in the DAS data and how they looks like in the DAS data. Events like earthquake, active source test, vehicle passing, and also rain and hail. And also after that, I started to compare the performance and sensitivity of the two interrogators that we have. And then I will go for investigating the signals of passing cars in both interrogator and analyze the effect of type and speed of the car in our interrogators. Okay, in the first step, I developed pipelines for loading and reading the DAS data. As I mentioned, DAS data creates big data, and we are facing the big data when we want to work with the DAS. So at first, I used the H5Py package for reading the DAS data, and also then I used the DAS package for managing the data sets and choosing the best part of the data and loading that part in the memory and do more analysis on that. And another point is that each interrogator has different metadata type, and I developed different pipelines for working with these different metadata type for each interrogator. After that, I started to develop pipelines for pre-processing the data, which is the converting the phase difference to the strain, because we need something to make sense for us when we calculate and doing more analysis. And also after that, I detrained the data for better management and handling during the processing and analyzing. And in the next steps, I developed pipelines for processing the data. So the first one, I create function for calculate and plot the power spectral density, PSD of the data. Here in the top figure, you can see a time series, which we can get from each channel of the DAS. And by using this function, we convert it to a PSD, which gives us the frequency content of that time series. And after that, I developed a function for calculation and also plotting the probabilistic power spectral density, PPSD. In this plot, we can see the probability of each amplitude for each frequency content that we have in our time series. And also I developed a package for, developed a function for calculating and plotting the spectrogram. In the spectrogram, we can see the frequency content for our time series in each time. For example, in different times that we can see that what's the frequency content for that time. And also I used and create some functions for filtering the data. The first one is the bandpass data, which I think most of you know that, which filters the data between two specific frequency, for example, 10 and 100 hertz. And also I developed a function for filtering, for FK filtering. In the FK filtering, we filter the DAS data by the speed of the wave, which is received by the DAS system. And after that, also I developed some functions for visualization the data, like something you can see here, and also plotting the waterfalls. In the next step, I will show some events that detected by the DAS during my internship here. The first one is in the left plot. You can see a earthquake signal in the DAS system, which related to earthquake in Indonesia in July 14th, and it took some hours to receive and sense in the Socorro in New Mexico. And also in the right panel, you can see a waterfall of heavy rain and hail in Socorro in July 14th again, which started around 1:20, 1:25 in the UTC time. Also, we did the active source test in that location in the Epic. We did 3 tests, and you can see the spectrogram of the data for both interrogators, Scintilla and Phoebus. And by analyzing this spectrums and also plotting the waterfalls for all of them, we can compare the sensitivity and the functionality of the interrogators together. Here in the top plot, you can see the results for the Scintilla, and in the bottom one, you can see the Phoebus results. Also, we analyze the passing car, and also we did the passing car test and analyze the results for both Scintilla and Phoebus. Here you can see the spectrogram for the Scintilla and Phoebus again for one of the channels. As you can see here, the passing car signals are so clear in the Scintilla, but they are not so much clear in the Phoebus, and we are working on that to find the reasons. And also in the left panel, you can see a waterfall plot of the passing car through the cable. The X plot shows the distance and the Y plot shows the time. And here you can see the car signal so clear. And by calculating the slope of this plot, we can find out the speed of the car, which is 25 miles per hour. Okay, still I should work 1 month more on my project, and I plan to first focus on car passing and characterize passing cars using that signal, and also analyze vehicle size and speed based on signal patterns and propagation characteristics. And also I want to investigate the background noise floor and try to remove them from the data to improve understanding of event signature. And also I plan to comparison both interrogator units, the performance and sensitivity, and also try to align and synchronize the data to match time and spatial channel locations. Okay, in the last slide, I want to acknowledge my mentor, Gizem, who helped me so much during this internship, and also the entire sensor group, especially Chris. Also, I want to thank Kelsey for her support and guidance during this internship, and also all the amazing interns I worked with during this summer, and also EarthScope, and everyone who made this experience possible for me. Thank you so much.
Nice work, Erfan. We have a couple of minutes if people have questions.
Kelsey, this is Donna. I have a question.
Hi, Donna. Yes.
Hi, thank you for that presentation. I'm wondering if you could share like the most surprising thing from your work this summer. What were you not expecting?
Let me go to the previous slides. One of the things that I was so much interested was the earthquake, because it wasn't so much so high earthquake. For example, it wasn't a strong earthquake, and also it was so much further from the Socorro in the New Mexico. But still, you can see here we can detect the primary wave and also a secondary wave in the DAS system so clearly. Although usually DAS system, the sensitivity of the DAS is not as high as other, for example, seismometers and other instruments, but still we can detect the events like the earthquake so clearly in that.
Thank you.
Sure.
All right, we got a question in the chat. What are the sources of background noise? Christine wants.
It depends on the location or other reasons. For example, in some data sets, let me bring it here. For example, in most of the active source test, and also before and after that, I can see some frequency content below 200 hertz. And I saw it also during the night. And I figured, after talking with Gizim, I figured out, okay, this can be because of the AC system, and also all other instrument makes noises in the EarthScope, in the EPIC. And also there are other kinds of noises that could affect, for example, sometimes the wind can affect our data set and put some noise on that one. And also it depends. In my research here in the University of Washington, I'm working with the underwater acoustics, and it depends on the location of the where we deploy the cables. And for example, at that place, we have other sources for the noise.
Awesome. All right. Thank you again, Erfan. We're going to move on, but feel free to ask more questions in the chat.
Thank you so much.
Thank you. Okay, and next we'll hear from Riley. Riley also worked on DAS, but with Chris Calvalich. So Riley, go ahead and take it away when you're ready.
Thank you. I'm going to start. So, hi everyone. I'm one of the other DAS interns, Riley. I work with Chris in the summer. Our main project is imaging the near surface using DAS ambient noise autocorrelation functions in central New Mexico. A little bit about myself. I am a PhD candidate in Michigan State, and I'm actually graduating next year. My PhD project mainly focused on subduction zone processes, especially the Tonga subduction zone in the South Pacific and Pimpian Blast Lab in the South America. My main project is to develop a new inversion method on seismic attenuation tomography with a very strong focus on statistics and HPC. In my free time, I really love rock climbing, like all sorts of sports, skateboarding, hiking. I just did my first ever 14er in Colorado weeks ago. I really love interaction with people. So during my internship in EarthScope, I got the chance to talk to a lot of people that actually reshaped my future goal. I feel like I'm so determined to work in a science adjacent area right now. So our goal as a DAS intern, everything I work should be very relevant to DAS. Thanks to Erfan, who just explained every detail about DAS. This is again the map of the DAS cable and the EPIC facility in Socorro. Our first accomplishment was an in-person field work in Socorro with Chris, Gizem, and Erfan. We learned about the DAS instruments from the computer lab to the field. And this is my first time working on DAS data. So I started off exploring the DAS data, try to visualize the signals from the local wildlife. And the third bullet point is our main project this summer. We're trying to use the DAS data from those cables and use a method called autocorrelation function to try to image the subsurface structures. So field work. We kind of work as a park rangers because after a heavy rain, those DAS cable might be exposed to the air. If you see something like this, the next thing would be Chris using his shovel covering up those DAS cables. And we also spend a lot of time and learn to splice and terminate the fibers, starting from the computer lab to the actual field. And on the last day, we did a very cool active source experiment using a shot track. A fun fact about this is, according to our DAS data analysis, the speed of the shot track in the field was 2 miles per hour. So my first little project is to visualize the signal. There was a game camera along the DAS cable that recorded a coyote which like passed through the DAS cable, and the circle signal is the signal of the coyote. I practiced plotting it in both time domain and frequency domain, and after that I got super familiar with DAS data. And then this is our main project. Again, this is a map of the DAS cable deployment. What's interesting is if you look at the four black triangles in the field, that's for broadband seismometers. I was really lucky to join the other internships, the orientation of the Geo Launchpad and recess interns. We deployed those for seismometers. In this project, I used a month of seismic data from those four broadband seismometers and the day of DAS data. To visualize the data, this is 5 minutes of record. X-axis is channel number. Like every channel, you can regard it as a separate seismometer, and y-axis is time. So if you just look at every single vertical curve, it could be some like the seismic wiggles you're familiar with, like this. I also plotted the four broadband seismometer signals on top of them at the relative location to the DAS cable. Those are like after a lot of pre-processing, like filter and demean the trend, stuff like that. Our method is called autocorrelation function. To understand it, when calculating autocorrelation function, we basically compare a serial signal with a delayed copy of itself with like a lag time. When you look at the overlap signal, if they're very similar, we can get a high autocorrelation coefficient. If they're not similar, the autocorrelation coefficient is kind of small. Based on this idea, we did signal processing with a lot of different steps, and also, a lot of tests with different parameters. I just put all the technical jargons here in the middle in the word cloud, but feel free to ask me any questions about the details of all of this. And this is an example of the autocorrelation function of one of the broadband seismometer. We use 1 month of the data. X-axis is again the autocorrelation coefficient with a high autocorrelation coefficient, either positive or negative. They mean we have some sort of similar repeated signal. And y-axis is lag time. And geophysics, you can kind of understand to be proportional to depth. The quick takeaway from this figure is those peaks can tell us about a boundary beneath the Earth and with different velocity contrast. So the final result, before that, I want to review the original data again. X-axis is different channel, which are like different seismometers or different distance to the original station, and every vertical line is supposed to have an ACF curve. We just plotted every 15th ACF for all the channels to make it easy to visualize, but the right figure is the same as the left figure, but instead we use heat map. The very quick takeaway from those two figures is we're very confident to spot 4 different stratigraphic layers, and there is a slight west dipping trend. To fully explain it, we combine it with previous geological information and plotted a cartoon. On the top, it's still like the 4 seismometers and DAS cable. And beneath the Earth, we have 4 layers with different materials. Remember the shot track we showed before? We also worked on multi-channel analysis of surface waves. And the takeaway from this figure is we can use 350 to 400 meters per second to be the velocity of the steady area. So our final takeaway is we do see a slightly west dipping fault, and we can calculate the thickness of each layer. Like gravel has the thinnest, it's like 10 meters, and pebbly sand has the thickest layer in this context. We submitted an EDU abstract, so please come and say hi and hang out with us. We will keep working on this next semester, so we'll definitely have some more updates. And finally, thank you, Chris and Kelsey, for working with me on all of those stuffs. And thank everybody who has worked on my abstract, my figure, and like gave me so much different insights on my career choices. Just like a very, very big thank you. You really didn't know, you changed my life. That's it.
Nice work, Riley. Great presentation. Any questions? We've got one in the chat here, and Shelly, then we'll go to you. Christine wants to know, to what depths can DAS image the subsurface, and can you say anything about horizontal or vertical resolution?
This is a very good question. Specifically for autocorrelation, we only saw a handful of paper talking about it. It's not impossible, but we're still unclear about what max depth we can go to. Our previous goal was actually to image the magma body integral, which is like 19 kilometers. We wasn't able to resolve it this time. It doesn't mean we cannot see it next time. It's like dependent on the signal to noise ratio, dependent on like a lot of different things. It's still very potential, but we're not sure to what depths we can resolve, especially for autocorrelation. But there are some other techniques. It's called like they somehow use cross correlation. It's very similar to autocorrelation, but that's like a little bit more mature, and they can resolve the mall hole, which is like several kilometers in depth.
Awesome. And Shelly?
Hi, that was a great talk. I'm curious about the application to wildlife and I guess wildlife monitoring.
Mhm.
I could see that you could see it in the data that the coyote walked through the system. But do you know of any practical applications that have been done with wildlife monitoring and DAS?
As far as I know, the whale monitoring is very mature. A lot of people are working on that, collaborating with biologists. That is very cool. And Chris also told me about one paper. They put DAS on the tree and they monitor the insects and bugs. So yeah, it is kind of popular now in DAS, especially in whale monitoring.
Oh, thank you. That's really cool. Appreciate
Mhm.
it.
Mhm.
Awesome. All right. Thank you so much, Riley. Great work. Okay, next we're going to hear, we had three science communication interns this summer that worked with Scott and Emily. And so we're going to hear from Beck first. Beck, go ahead when you're ready.
Thanks, Kelsey. Yeah.
Mhm.
Okay, hi. So I am Beck. I'm one of three science communication interns. You're going to hear from the other two next. So because science communication isn't so much like one tangible project, I'm basically just going to showcase the work that I've done this summer for you guys. So first, a little about me and who I am. I am a PhD student at the University of Oregon. I'm going to be starting my final year this fall, so I'm excited for that. My research consists of doing seismic tomography at volcanoes, so trying to image melt in the crust, magma transport, how much of it, where is it going. Particularly for me, I look at Santorini and the Galapagos volcanoes. So this picture up here is at Santorini from the actual center of the caldera, which is pretty cool. And some of these are also from the Galapagos. So I broadly labeled myself an explorer because I like camping, hiking, fishing, anything outside, especially over here in Oregon. And I like photography, as you can probably tell here. I like wildlife photography a lot. That's probably my favorite hobby. And I'm also a middle school girls soccer coach on the side. So for this internship, I had three pretty distinct and tangible goals. The first of these being I wanted to learn how to create science communication videos. I felt already decently confident in my verbal and written communication skills, but and even like creating, infographics and that kind of thing. But creating something that's actually like moving in a video felt a little daunting. And so one of my goals was to learn how to do that. And then also decide if science communication is a career I want to pursue. So as I'm entering my final year, my PhD, I have to start figuring out what I'm going to do afterwards. And then I just wanted to generally learn the most common software used in science communication. So see like what Scott and Emily use on their day-to-day, what it consists of, and make sure that I'm just familiar and can use all of those softwares. So right off the bat, my first and biggest project hit goal one I created about a 5.5 minute long video. You can find it on the EarthScope YouTube, so it's too long. I can't show you guys here, but you should go watch it. And this video is mostly for Earth Science Week, which is this October, and the theme is energy resources for our future. So I made a video talking about different energy solutions and different ways scientists, like specifically geophysics scientists, are able to locate and manage them. So this project required me to use Adobe After Effects and Adobe Illustrator. Illustrator I was already pretty familiar with from, making posters for conferences and that kind of thing, but I still got to learn to use it in a different way. So I would make the little characters that I used in Adobe Illustrator, and then I would import them into Adobe After Effects. And this is something I had never used before and was pretty unfamiliar with. So that was really cool to learn. I feel way more comfortable with it now, and I was able to, make the actual movement and animation happen. So this is just a little GIF from the seismic tomography part of it. And then written work. So I helped fill in a gap in the What is Geophysics section of the website. So I made 3 main pages about seismology and seismometers and seismic tomography, because I was able to kind of apply the expertise I already know from my research and still develop those writing skills. So it was a win-win for everyone. And this required me to learn WordPress, which I was basically unfamiliar with going into this internship. So it was good to know what is, I think, the most common website platform, know how to use that and stuff. So then also probably my favorite part of the internship was the Kamchatka earthquake and the event response. So yeah, that was just like really cool and exciting for me to get to see sort of how that happens here, So when, an earthquake happens, especially such a big one like this, how you guys actually respond to those kind of events, and particularly in the social media side of things, right? You're trying to get things out quickly and trying to figure out what's going to be the best information to get out. So it was really cool to talk through all of that. So to help with this event response, I plotted up the global seismic network receiving the earthquakes. So that was really cool. And this is the actual plot of all the different stations that I was able to find that received some sort of signal from the earthquake. And then I made this nice little plot. So that was fun. And then also I sort of felt inspired by Emily and her awesome little shorts and TikTok style videos. And I made a similar one. Again, you should go watch it. It's on the YouTube shorts, or the shorts part of the YouTube channel, and also on the other social media platforms. But it was my first time making this kind of video too. And so it was really fun to, do that. I did basically like a pasta breaking analogy for magnitude of earthquakes to kind of help visualize the logarithmic nature of it. So yeah, that was super fun. That required me to learn CapCut, and I already knew Python really well, so that was fine. And then also just a little bit of manipulation in Adobe Illustrator. So this was also cool because I was able to learn a different type of science communication video. I was able to make 2 different ones over the course of the internship. And then sort of just generally social media. I was interested in social media and did a lot of work with that. So most of the posts, for those of you, hopefully most or all of you follow EarthScope on any social medias. A lot of those posts you saw I was creating. So particularly all the intern interviews. I made those posts and a lot of the Fieldwork Fridays, and then, some other sporadic ones here and there. And then sort of on top of that, what was really cool is I also helped out a little bit with the social media analytics at the end of the month. So I got to like make the posts and then also get to see the analytics of like what works and what doesn't work, and why, and sort of get to also investigate that while doing it. So it was cool to see both sides of this. I thought that was really fun. And so to do this, we use Loomly to do social media post management. So it was cool to learn. It had a little bit of a learning curve, a little bit of like specifics here and there, but it's really nice and it's a really helpful tool. And then just Excel for, spreadsheets and doing the analytics. And then lastly, sort of some other stuff here and there. So like I said, I did the posts for the intern interviews. The interviews were very much a team effort. You're going to hear from the other 2 SciComm interns. But so mostly my part in that was putting the posts together, but I did do a couple of the interviews also. So it was cool to get to learn Riverside, the interview software, and work on those interview skills and that kind of thing. So that was really fun. And then also I made some poster templates. So there's sort of a new wave into these new design of posters. There are, hundreds, if not thousands of posters at some of these conferences, and absorbing the information from them is a lot for a participant. And so people are starting to steer more towards simplistic posters that make your takeaway really obvious, right? So that people walking by can actually understand what your poster is trying to convey. And so in the spirit of this, I made about 4 more poster templates. Some of these are very much more towards this end member of simplicity, and some of them are kind of a hybrid in the middle. So I think that those are going to be available to you guys before AGU. So at least check them out. You don't have to use them, but hopefully they can be helpful for some of you. So yeah. So just going back to the goals really quick, obviously I have hit all of these, which is awesome. I definitely learned how to make science communication videos. I made 2 different kinds. And I feel really comfortable, like I could make any type of video like that again. And I do feel like science communication is a career I want to pursue. This internship has been so, so awesome. And I love making this media and making stuff like this, and I'm going to keep doing it. And yeah, as you can see from all the pictures here, I definitely learned at least the most common software that Emily and Scott use. And I feel much better about my understanding of like what a job in science communication looks like. So big shout out to Emily and Scott for our daily meetings and all of their help and support, constantly throughout the summer. And thanks to Kelsey for, wrangling all the interns, keeping us on track and all of that. And so many more people, thanks to Alex and Viridis for all the, we were able to bounce ideas off each other and, collaborate on some of this stuff. So yeah, it was really awesome. And obviously this is a quick presentation. So if you want any more details about me and my work, that's my website. And yeah, you can find me on the UO student directory and that kind of thing. So one last thank you to everyone for this internship. It was awesome. And I can take questions now. Bex, I think you got a couple of my emails. I don't think I got any of yours, at least.
That's funny.
But yeah.
If you got mine, you probably would have just deleted them because they're only budget spreadsheets.
Real exciting stuff.
Hey, Kelsey, I have a quick question.
Yeah, please.
So, hi, Beck. Thanks for that. I'm just curious, you only worked with Emily in the social media just a little bit, but did you have any suggestions for Emily and for EarthScope about, how to better reach, your demographic of graduate student, or any, things that you noticed that we were doing really well or that maybe we could do better?
Yeah, I do think we would talk about these things a lot as a group. So I do think we being the SciComm interns and Scott and Emily sort of discussed some of these strategies of what works and what doesn't. I don't know that I have anything in particular off the top of my head right now. I think it's probably a longer discussion because I don't think it's so simple. I think the short answer would be that overall, I think EarthScope is doing a really good job. I think there's always room for improvement. And, especially with social media, it's always an evolving platform. And even just the way feeds are prioritized is constantly changing. And so I think just staying on top of that is really tricky. I think overall, the social media does a very good job of balancing having to communicate both with a scientific public, scientists and grad students, and also kind of the lay public that's interested. It can be really tricky to create posts that everyone is interested in.
All right, we're going to move on. Thank you, Beck. Excellent presentation. So much work done. And we'll hear from our next SciComm intern, Viridis. So when you're ready, Viridis, go ahead and share your screen.
Good afternoon or good morning, depending on the time zone that you're at. My name is Viridis Miranda. I'm also a science communication intern with Alex and Beck. I currently am a graduate student at the University of Puerto Rico at our Department of Geology. My master's research project is on seeing which type of seismic receiver function technique I could use for the moon in order to see the crust, the mantle, outer inner core, or even possibly discontinuities. A little bit about myself. So here in Puerto Rico, what got me so immersed in social media and how to do educational outreach is the opportunities that I have been given. I talk from time to time on radio talk show hosts, which is WKJB, It's a public radio show that showcase how to explain geology and how to explain research projects that us graduate students do in layman's terms, which is super important. I also do podcasting with other two of my colleagues and fellow graduate students as well, which is Carla Torres. And we communicate also the seismicity of the island. After the 6.4 earthquake happened, it had a big impact in the seismic sequence, and there was a lot of damage during the island. And it's very important in order for us to communicate what has been going on in recent years and how does earthquake form, and being able to use our bilingual knowledge in order to communicate that science out. Also, I like doing like volunteer work at museums, also to showcase our field department. We are the only geology department in the whole island of Puerto Rico, which is a fun fact. My initial goals for this internship was in order to highlight my interviewing skills a lot better, to perform a lot better my public speaking skills in English, and in order to communicate my science as in fun article in order for many people to understand. One of the articles that I have been editing and working on with Emily and Scott is on moonquakes and how to explain that moonquakes are the equivalent of an earthquake on the earth, but it's not due to the same mechanism. And I really want to showcase that and transfer my graduate work in order for people to also know about it as well. Also, I've been doing interviews a lot. I love doing interviews. I love talking with people. I think that's one of my God-given talents, and I'm very thankful and happy for that. But this is also a team effort. So Beck and Alex has also done interviews to a lot of interns. I got to do Beck's, I got to do Alex and Asif, which is in the bottom. So thank you so much, everyone, for saying yes. Everyone told me that it was very engaging, and that was my goal. I also got interviews by employees as well, Michael Hubenthal and Cami Alpizar. I got to interview them as well. I got to learn about Riverside is a good podcasting radio show recording app, and Frame.io is used for video editing. On the bottom right corner is me doing a drop, cover, and hold because I want to do a specific video on what is the most efficient method in order to protect yourself with a Spanish voiceover and beat it to it. Because I really want to use my native language as well in order to communicate science to other types of scientists that live in the Caribbean and live in South America and other Spanish-speaking countries. Also, this is the fact sheet that has the earthquakes on one side, the energy comparisons on another side, and it's still like under construction because I really need to learn like Illustrator. So one of the things that I really wanted to learn is on graphic design because even though I did my toes like on how to use microphones, how to use like video editing software and transcribers, I didn't really know how to communicate my science using graphic design. And it is very challenging in the sense that you have to learn about margins, have to have a lot of patience for it because sometimes when you translate from one language to another, sometimes the boxes don't fit within the aspect ratio. So you really have to be very patient with it, very kind to yourself. But this is the fact sheet that will be available to everyone in Spanish with the energy release and the earthquake comparisons too on both sides. I like to also, right, before I thank everyone and all the effort, this internship has really given me a confidence boost. I think all of us at some point, we got imposter syndrome saying if I'm cut out for this or not. And the only way to find out about it is if you try, right? And I tried. I really did try. I really wanted to boost my skills, my social skills as well, in order to boost my science skills as well, because one of my goals as a graduate student is to make science available for everybody and for every single type of population that everybody can listen to it and understand it. And also use, my native language in order to communicate to others and to also for them to learn English as well, because it's also a universal language. So that's one of my big two goals here that I learned in the internship. Also, I like to thank a lot of my team. They have been very patient with me. They have been giving me pointers, recommendations, seeing what I can do in order to better for it, because we each individually have our talents in graphic design and video editing. And I am really lucky about the team that I had with Beck and Alex. So I like to thank them a lot. They did a lot of the Loomly posts and the WordPress posts as well. I'll be a few more days with Scott and Emily to learn about that and get my stuff done. And also I'd like to thank Michael Hubenthal, Camille Pissar, Tammy Bravo. These are the employees that were willing for me to get interviewed because these are really the people that I looked up to. And hopefully in the future, I get to do something very similar. I'm really big on education and on pedagogy, so I got that opportunity as well. Kelsey also answered all of my questions throughout the whole internship because I was kind of nervous about like the mechanics of it, but you were a good navigator on that. And also Riley that joined our team as well. And every single intern that has said yes on the interviews, you guys were really great, were really kind to me, especially when I had to like switch to another platform, which is Zoom, because that's another thing. When you're doing interviews, sometimes circumstances happen and you have to think on your toes and kind of improvise, but kind of have to be very, how should I put it, very nice with your wording and to not make it look like awkward, which is the kind of true talent that you have there. So thank you all. And thank you for giving me the opportunity.
Nice work. Thank you, Viridis. Very interesting. And Shelley, I think you had your hand up, or were you just clapping?
Well, I was clapping, but also just interesting that this is the second time in the last 6 months that I've talked to a graduate student who is working on moonquakes. Alice Turner, who is a former intern within our programs, also has been studying moonquakes. So just a interesting overlap there.
Mm-hmm.
Oh, that's awesome. What's the person's name again?
Alice Turner.
Alice Turner.
Yeah,
Awesome.
I
And
can
Viridis,
connect you guys.
we have a question in the chat too from Michael. What is the biggest misconception that you encounter when discussing the moon with the general public?
Oh, well, there is a couple. There is a couple. So when I started doing my literature review on my research project, one of the biggest things that there is, it's like, is shallow moonquakes have a tectonic origin or not? And in the literature, what it does says is that gravitational forces does a gravitational pull from Earth, and that causes cracking and rifting and causes faults within the moon. So it kind of hints that it could be a possibility, but it has never been like really, really proven yet. And that is the most things that I have to highlight and and explain. Like it's not like there is active tectonics up there like right now. And what I do is I use a tectonics here in Puerto Rico in order to explain what's occurring in the North American plate and the Caribbean plate and earthquakes and stuff like that. And I was like, but if I stand next to a seismometer, the vibrations that get picked up are mine, not an earthquake. So it's kind of like the moon. The moon has different stresses like tidal forces or gravitational forces, either stresses occurring through changes in temperature and also meteorite impacts. And those are the things that I have to highlight most of all within the moon. Also, this is really awkward, but I have encountered people that really have asked me, like, right up to me and saying, "How did you know that Apollo really happened?"
Yeah.
So that's another thing that I have encountered. But I do attend it gracefully. I was like, you know, as a scientist, you get a bunch of things, talk to you, but I do show them, the seismometers and the seismic data and the waveform data that I extracted through Iris. And I go through the motions. I show them my laptop and go through the motions and explain bit by bit. And then they kind of go into the understanding of it. Like an earthquake is not only induced by tectonics. And that is the biggest thing that I have to showcase.
Mm-hmm. Nice. Good question. And unfortunately, it's not made of cheese. Bummer. I'm very, very sad about that, actually. All right. Thanks, Viridis. That was awesome. All right. Rounding out our SciComm interns, we'll hear from Alex.
All right. Hello. Let me share my screen. All right.
Beautiful.
Hi, I'm Alex. I'm the third of three science communication interns. So similar to Beck and Viridis, I'm just gonna sort of walk through my showcase of work for the summer, because what I really appreciate is that all three of us have gotten to do like just a very diverse amount and types of work. So there was always something to do. A bit about me first. I'm a rising senior at the University of Georgia. I'm majoring in marine science. So far, my undergraduate research has focused on the effects of climate change in Greenlandic fjords, specifically the change in physical circulation. Coming into this, I've always had a really strong passion for creative media and art, and I've been working as a tutor for about 6 years, so I really love teaching, especially science. So those two areas of interest together have kind of come together to give me a really strong interest in science communication. Before coming into this, I had some specific goals. I really wanted to gain formal Adobe Illustrator experience because I kind of have always thought of that as the pinnacle of, graphic design software. Before, though I had used some Adobe Suite, so like After Effects, that's a video editing software. I hadn't really made anything beyond like hobbyists creations or informal stuff. That being said, I really wanted to focus on synthesizing like my academic knowledge and these creative skills, and just combine the two. And then a sort of a side thing was focusing on more collaborative workflows, so these group projects, because I hadn't really been involved in such a thing before. So I wanted to really work on my teamwork skills essentially. So moving on, to start off, I'll show some of my Illustrator and like illustrative media. So one of the first things I worked on was this redesign of a lenticular ruler. So I included a GIF here to see what it would look like. But it's these four slides on the front, and then we have a little backside here. And that QR code will link to the existing Earth Layers interactive poster that already exists on EarthScope's website. So this was a really fun and a little bit challenging, but a really fun project to start off with. And going on from there, as we started to sort of ramp up the more social media aspect of things, I started off with a sort of carousel slideshow post for us science communication interns. So this one on our Instagram, you might have seen it. And this was really fun to do. I got to basically do whatever I wanted in Illustrator and make it look cool. And it was interesting to try to sort of it was like my first experience with making something specifically for social media. So it was interesting to balance all the different considerations of that. Oh, and yeah, here's just a slightly zoomed in version of that so you can see it a bit better, featuring Beck. Moving on from that, this is a pretty recent project of mine, only last few weeks that I did this. So these are sticker designs. So these two on the left and middle will be at AGU. A little polar bear and panda and python fighting. And then this little penguin will be a McMurdo exclusive, which is super cool to me. And so these were primarily made in Clips Via Paint. And to sort of give more insight onto what the process for making these is, I included a little time lapse of me making the penguin sticker. So I'm just gonna let this play. It's only like 30 seconds. So basically this is everything that goes into it, starting from a sketch, and then I go over it with like this sort of monoline pen. Then he gets his little tie-dye. And in between here are daily check-ins where I get feedback from Scott and Emily and Beck and Viridis about what I should change. And then here you get some equipment in the background. And then this will be finishing it up. And then there's the finished thing. So that was really fun to make. So, if I can go to the next slide. So as Beck and Viridis have also mentioned, another main thing we did was these intern interviews. So while Viridis and Beck did a lot of the actual interviewing, and Beck did like the social media posts, I kind of did all the in-between steps. So taking those like raw video files, putting them into After Effects to sort of like do the formatting and background and name tags and like intro, outro stuff. That also then went into transcribing. So some people didn't want videos. So in those cases, I just take the audio, I transcribe the whole thing using some like transcription software, edit that, and then I set up the web pages on WordPress. So when I hit publish, that's what actually shows up in like the news and features tab. And then here's just a little insight of what the making of that looks like. And then yeah, this is the same thing except for what the video editing part looks like. So I have all these layers of like the actual video clips, the names, the background, and all of that. So the sort of main time commitment and main project I had going on for the whole internship was a about 8-minute long original animation video about volcanoes. So Beck did a huge job helping writing the script, and then I took care of all the animation. So this was a huge commitment there's about this screenshot doesn't even show everything. It's about like 120 layers of stuff. There's even more stuff inside all of those. I think I spent probably like 15, 20 hours a week on it, especially in this last month. So I don't even know how many hours I've spent doing this whole thing. But I'm really, really, really happy with it. Here's some little progress shots of different frames from the video. So everything is hand drawn, like hand animated, manipulated. Um, yeah, and so the final video is up unlisted today, but hopefully there'll be a social media post for it relatively soon. And this will also culminate a poster at AGU with collaborating with Beck. Yeah, so I'm super, super excited about it. I thought I would show just a few. Oh, sorry, it's so loud. I thought I would show a few like little clips from the video just to see so you can see what it looks like. Um, so this will go up on the under like what is geophysics on the EarthScope website. There's like a hazards page, and then under that there's a tab for volcanoes. So this will go on that webpage. Yeah, just some more little shots of what it looks like. I like this part. You'll hopefully get to see it in a second. So like stuff like this, everything is hand drawn. This takes like just, I think this 10 seconds took like probably 5 hours to make because I drew everything in it. But it was just so much fun, and I really learned like how much work goes into these videos that you know probably see online, like TEDx animations. It's just a huge time commitment. Okay. Yeah, then to wrap up, my goals towards the end, I feel much, much more confident with like the standard spread of communications programs, especially Illustrator, which I hadn't used before. I feel a lot more comfortable working as part of a team, particularly with the interviews, because they were done both in parts and on a pretty quick turnaround time. I think we've been putting out 2 to 3 a week. Um, and how to best manage projects with multiple contributors. So it's not always most effective to have like each person do a little part of it. Sometimes, you know, different people have different skills. And so figuring that out was really good. And then, yeah, just understanding the ins and outs of what a science communication job actually looks like. And I really, really enjoyed it. Yeah, so just to finish, thank you to Emily and Scott. Nothing would have been possible without you guys. Like, I appreciate every bit of support you gave. Kelsey, to you too for organizing everything. Beck and Viridis for all your help throughout the last few months, and everyone else at EarthScope. Thank you so much.
Ooh, those stickers are gonna be hot, Alex. Great presentation, Shelley.
Hey, yes, great presentation. Wonderful to see these stickers. It's going to make me have to go to like a conference to get some unless I have an inside edge somewhere. Um, I had a question about the hand-drawn illustrations, which it's great that you were using Illustrator and all those tools. And I know that Illustrator is now providing some AI support for drawing. Um, what are your thoughts about AI in
I
scientific illustrations?
For myself, at least, I stay as far away from that as I can. That's why I included that little time lapse of me drawing the penguin because I'm very, very like, just for my own purposes, I really don't like to use it, especially for scientific content. For creative content, maybe that's a different story, but for scientific, like there's just so many things that can go wrong with it. Especially if you're relying on it for accuracy, I don't think it's even remotely reliable. Um, for creative areas, maybe there's some leeway, but yeah, personally, I just prefer to do everything myself. Just that way, if something is wrong, it's a lot easier to sort of trace the mistake. Like, I could have made a mistake reading something, or drawing something, and it's an easy fix instead of sort of attributing it to the nebulous AI. Like, yeah.
Yeah.
Yeah, thanks.
So talented. Michael has a question. Could you talk a bit about how you balance accuracy versus accessibility in animations?
Yes, so that was definitely one of the big learning curves for me in the volcanoes video because I don't personally have a strong geophysics or geoscience background. So I was kind of learning some of the stuff for the first time as well. And in some ways that actually helped me because if I'm also sort of learning it for the first time, then I can try to understand how it could be best presented for a first time learner. That being said, especially with some of like the interior, like I think I showed a few frames, some of the interior volcano content. Of course, it doesn't actually look like that, But yeah, just like ultimately the goal is to communicate as straightforwardly and as much as possible while not neglecting accuracy. Um, and I was thinking about that every step of the way. And like, I think I found it helpful to sort of consult textbook diagrams once in a while, especially if I was starting on a new section. But ultimately, I think there's always going to be something that slips through the cracks. Like, there's always a balance you'll have to reach. Um, but yeah, so I kept, I, tr- but cut to, sorry, I tried to keep it as accurate as possible, reference diagrams. But in some cases, I did have to just make it look pretty. Um, but yeah, it's a trade-off.
Nice. All right. Thank you, Alex. Okay, that's it from our SciComm interns. Now we're going to hear from Asif next, who worked with Tammy Bravo and Sarah Wilson on Cloud OnRamp.
Hi, good morning, good afternoon, based on where you are. Let me share the screen. Awesome. Hi. So I'm Asif Ashraf. I'm a PhD candidate at the University of Oregon. Just a little bit of background of mine. I'm a geophysics graduate student at the University of Oregon, and my primary project is about developing a 3D seismic tomographic model for the shallow part of the Cascadia subduction zone. And I have some other research projects which mostly revolve around basic seismology or something about Cascadia subduction zone. About the project that I've been involved in throughout the summer, which is the cloud on-ramp, that probably you know about it. But the basic idea is the EarthScope is moving their SAGE and Gauge data to the cloud. Now we need some infrastructure inside of the cloud to access those data, right? So this is where the GeoLive is coming from, which is basically a Jupyter hub where multiple people can come in and do their access this data and do all kinds of analysis in that. And GeoLive provides a lot of cloud-based geophysical research tools, so people can use it for their own research, right? So this is where I come in. I come in to mostly support the EarthScope effort to expand the access to the cloud-based geophysical research workflow. And the initial goals of this internship was first to review the existing notebooks and documentation, then based on that, develop the user-facing tutorials and improving the documentation that helps researchers to get started their journey to the cloud. Now, coming from that, so coming to this internship knowing mostly nothing about cloud computing. So the first question I had in my mind, which is, why should researchers move their entire workflow to the cloud? So all the things I have done from this point, that that has this question in the center. So if you divide my entire contribution, it can be divided into two different sections, which is first, I developed some Jupyter notebooks to demonstrate the cloud-based computing. I also tested the workshop materials for the GeoLive platform. And I'm going to talk about this first. So there's a MS Pass short course that happened in late July, and I tested the materials to detect the bugs and enhance the user experience based on the text available. Then I also tested some capacity limitations, then memory usage, and that has trickled down into improving the GeoLab capacity for each user. So that something really good came out of it. Now, this is what I want to talk about most, which is I spend most of my time developing these notebooks. And after I reviewed all the previous documentation, I thought I could divide the entire workflow into three different segments. So first is traditional workflow versus the cloud optimized workflow. In that notebook, I give a very simple analysis pipeline for the SAGE data, which is you have some earthquake location and time, and based on that, you develop some inventory and read the seismogram from those stations, then do some instrument correction, phase picking, trim the seismogram, and do a Fourier transform analysis. Now, this is a very simple, basic seismological workflow that most people are familiar with. Now, in here, there is a slight twist, which is when you're reading the seismogram for the stations, you can either download it from the FDS and web server in traditional way, which I knew about it. But now you don't have to download it. You can just stream it from the S3, which is the storage service for the cloud computing, and you can just stream it. You don't need to download it anymore. So this is the cloud optimized version of it. So your data is analysis ready and cloud optimized. So I took all of those processes into a single function that I'm calling analyze earthquake, and it has several user modalities. But the most important modality is like you can choose to either download the data from the FDSN, or you can stream the data or access the data from the S3. bucket. So if the users try to go into different ways and compare their analysis, at the end of the notebook, it shows something like this. If you're if you're accessing data from the cloud, it takes about 30 seconds for 7 stations to go through all of these processes. And if you're downloading the data from the FDS and web server in a traditional way, it takes about like 45 seconds. So you're saving 15 seconds for 7 stations, right? Now, that takes me to the next notebook, which is parallelization with Dask, which is in there, I'm using the same function. And now I'm only streaming the data from the S3. And the only difference is before I was accessing the station data sequentially, but now I'm accessing each station parallelly. So all the stations are together using the Dask, which is a Python library that allows you to do parallelization. Now, with the Dask, you reduce the time from 30 seconds to 18 seconds. In there, you're saving about 11.8 seconds. So in total, for 7 stations, you're saving about 26 seconds. But wait, seismologists don't do just 7 stations; they do 1,000 stations. So that saves you about an hour. But they don't just do in one time, because in geophysics we do it iteratively. So you're trying to minimize against your observation. So you did 10 iterations, and that saves you about 10 hours. So okay, so that's pretty damn good reason for move your entire workflow to the cloud, if you ask me. So that trickles on from parallelization to the scaling, which is about the next notebook. There, I'm trying to make a machine learning notebook that showcases the actual capability of the cloud computing, where you can data mine using the same function and train it using a very simple. This is a CNN architecture, the UNet, a very simple UNet, and train it through that and get some validation. So the workflow for that notebook works something like this. You initialize the Dask gateway. The Dask gateway is where you can visualize all of your parallelization that are happening in real time. And I built a very basic unit, and that's adaptive. I data mined using that function that I have just described. Now, I made this unit adaptive because I want the users to be able to put as many features as they want inside of the CNN algorithm. So they can put any number of waveform features that they want, which is one of the very common things is STA by LTA, which is short-term average versus long-term average. People have been using that to peak a P wave and S wave for decades. So if they want something like also like a spectral thing, if they want to put those features inside of the unit, they can do that because it's adaptive. So at the end, it's training either in CPU and GPU, and GeoLab has now capability to run things on GPU, so they can use the GPU in real time and see the difference and get the power of cloud computing in their mind. In terms of validations, they will see something like this at the end. So this red dash line is a true peak that I picked with the size bench. That's already a model that's available through our EarthScope web service. Now, with the only raw waveform data, it doesn't do very good because one thing, all these notebooks are designed to stand alone. So they're also designed for an asynchronous workshop. So I don't want them to go through like 10,000 samples for like 10 hours because they're just not feasible for a workshop. So I want them to train on like 20 or 30 seismograms. Now, if you train on only that small amount of seismograms, the performance is not going to be very good. But if you put some physics informed features, for example, like the STA by LTA or some spectrogram, then it gets pretty close and very small data set. It's not a very ideal case of machine learning, but it showcases that you can scale up your entire machine learning or whatever workflow that you have. And all these 3 different notebooks come in 2 different flavors. One is the Sage Gauge that I've just showed. There is another flavor that's the Gauge data, using the Gauge data. The only difference between those is the science itself. And each of the notebooks, I have just talked about the technical aspect of the notebook, but each notebooks are designed in a way so that they're very user friendly and tailored to both high level analyst or someone like at a very beginner level. So it introduces what they're going to learn and why do they need it with figures and diagrams. Then in the code block, it gives them a stepwise workflow, so 1, 2, 3, and it has ample comments so they can connect to the introduction. And at the end, it gives them a reflection question that, it's a thought-provoking question that helps them to think about the processes they have just learned and apply to similar environment inside of their mind. It's just like one basic learning block for the entire notebooks. Yeah, so I think I'm a little over time, so I'm gonna put my summary slide over here, and there the tutorial notebooks in this GitHub repo if you want to check and give some feedbacks. I'm pretty sure the team will really appreciate it. And thanks to my mentors, and thanks Kelsey, and thanks everyone that I have interacted with throughout this internship journey. I'm really grateful for this opportunity. Yeah, and with that, I'm happy to answer any of your questions.
Nice work. We probably have time for one question, or if we want to put them in the chat, maybe Asif, if you could watch for them in the chat too.
Yeah.
All right, super great. I'm going to keep us rolling. So if anyone has questions for Asif, please put them in the chat. Next, we're going to hear from Danielle. Danielle worked with Beth on the engagement team on educational data and resources.
All right. Cool. So I'm Danielle. I was the education data resources intern this summer working with Beth. And most of my work was focusing on like teaching near surface geophysics. So as a quick introduction, I am a geophysics PhD candidate with the Nevada Seismological Laboratory at the University of Nevada, Reno. Most of my research has been focused on earthquake early warning and basically trying to implement it in Nevada, though looks like most of my upcoming research is going to be more focused on like machine learning and like auto-identifying earthquakes. And then just some extra about me is I am very passionate about teaching. I really love teaching. I am that TA who is always available to students, and they always know they can just come into my office and ask for help. And I'm also very passionate about like crafting and trying to like introduce science in like other unique ways. So as you see in the bottom right there, my in progress geologic map cross stitch. So for my internship, a lot of it was about, like I said, kind of teaching geophysics. So one of the first things I worked on, and this also kind of ties into the next as well, was looking at the electrical resistivity tomography model on GETSI, which if you don't know, GETSI, we have all of the different teaching modules where the idea is teachers can come and like see how you can teach geophysics and like they can get real data to use if they can't, get their own equipment or have the opportunity to borrow it from us. So I went through the ERT module and I was just very thorough going through it, and mainly was like making changes to like really make it more understandable to students, make sure all the assignments, were like really readable and like could be used for like intro and not just like advanced courses. Because if you've gone through the ERT module, it's a very advanced one. It went to a lot of detail and a lot of technical, like higher level stuff. So the other thing I did was like go through it and like really make a whole like list of suggestions of all the different ways you could modify it so you could use it for a more introductory and maybe even a non-majors like introductory course. So like what things you can skip, what things you should focus on to, just get the best out of it. And then tying into that, I also made like quick guides for the new Super Sting ERT equipment we've got. So I made guides basically on like how you can use it, like how you deploy in the field, like what's the good process for it, like, and all the good tips and tricks, just like taking the big thick manuals we all are used to and just squishing them down into a couple pages that someone can really easily print out and take into the field with them, so all the setup and how to do like and run it. And then also as part of that, I kind of created like PowerPoints and some other guides for the instructor side on like how to really do the survey, like what you should think about when you're planning it, what safety things you need to think about it, and kind of like the good like kind of things you take into mind, like in terms of like what your target you're looking for is, like what's the material, how deep is it, and like to kind of help you plan out like the length of your survey, your spacing, what type of array you're going to use. and just kind of other good advice, like, good practices for safety and like the best way to kind of like take notes and kind of manage all that side of things. So other, we go. And then the other real fun project that I did is I helped out with the Teaching Near Surface Geophysics to Undergrads workshop, which is really cool. It's where basically it's an in-person workshop for like a week where we have like the GPR, ERT, and Seismic and GPS as well. The goal of like teaching instructors, professors, community college teachers, people who might actually want to borrow our equipment, and teaching and showing them how they can use it, like kind of the theory behind it, the way to lay it out, the way to plan your lessons, and ways you can tie it into the existing modules. So because I am a very seismic focused person and I have done many, many seismic surveys, I taught the seismic refraction portion. And I forgot to say, is a really cool part of it is it's in person at Colorado School of Mines. They have this like discovery lab where basically when they were doing construction a few years ago, they took the opportunity to bury a bunch of different targets in this field. So like concrete slabs and pipes and like archaeological sites and pretend graves, so that there's actual like targets that students can look for when they're, out there practicing. So as part of teaching the seismic refraction to people, once we were out there in the, at the school, so a lot of my main focus was kind of teaching people how to set up and perform the survey. So, like best practices in the field and like ways to help it go quicker and be safer, including things like the recommendations for how to use the sledgehammer and how to set it up. So students are less likely to hurt themselves or break something. And then also I showed them with Pickwin and ReferPy how you can pick the first arrivals. So Pickwin is like the software we kind of recommend to people. It's just not free, so you only get limited free uses. ReferPy is like a Python-based one. So some people who, already use Python were like down with that one, but some people were just like, no. So it was good kind of showing both to people because people did have questions related to both. And picking arrivals is always one of those things that takes a lot of practice. So it was good that we got a good amount of time to kind of work on that. Whoop. But kind of the big thing was making sure that all of these like, students, but, their instructors all know how to then take what we teach them and like teach it to others so that they know how to set up the surveys, they know how to use the equipment and can show it confidently to other people. I think sorry, skipped a slide. There we go. Yeah, so they know how to, set it up, but also that like they are confident to teach the theory to other people, so that they can show their students how to do things, how they can set it up, and they can show their students how to use all the software as well. And then the other important thing was that they know what to do with the data and they know like how to use this field experience to then teach it to their students. So, like they can teach their students to pick, or like they can just, print out the seismograms and have the students draw on them and you do pencil paper style, or like upload the data into Excel and do a little simple there. And, we also talked about ways to make it more advanced for like more advanced students, like, having their students do all the planning. So it was just a lot of good fun and a very good teaching experience. So I really did enjoy this summer, and I feel like the biggest things I learned can be really summed up as like a lot more good experience on like how to create like teaching materials, like how to make things accessible and understandable and, be more adaptive for different levels of teaching. And then it was just really nice getting more experience like teaching others, especially like students who, are more like colleague level than like the normal students I'm used to teaching. So it was definitely like a different experience and very glad to have it. So as an end note, just want to thank Beth for being a great mentor, Dee Dee for also being around answering questions and helping out, and DJ for answering many weird questions I sometimes have about like the different equipment that, I need a good answer to. So, and that's it.
Lovely job, Danielle. Great presentation. I'm going to try and keep things moving. So if we have feedback or questions for Danielle, if we could put them in the chat, that would be great. And Danielle, if you don't mind responding to those as they come in. But what a great project. So cool that you got to go and actually teach or watch or teach the teacher kind of thing. Love it. Okay, so next we're going to hear our last presenter today is Connor, and Connor worked with Sarah Deutsch in the project management office. So we get to hear what they've been up to.
Yep, so hi. Get this. Can y'all see it?
Yes.
Great. Okay, so yeah, my name is Connor Knorr, and I'm an undergraduate student at the University of Houston studying geology and environmental science. So I'm just going to talk a little bit about my experience this summer exploring project management tools and practices. All right, so first off, I wanted to start off by talking about like learning all of the actual tools and websites that I use because that was a really big goal of mine since I was very new to project management and always kind of did work in like research and stuff like that on more of like the science side, the geology side, rather than like seeing all this stuff that actually goes on in the background to like make the projects actually happen and work and be on time and all of that. So first off, I kind of kicked off with some online training from Google and IBM, which just kind of set me up with like a solid foundation of like what actually is project management, the methodology, the sort of basics about it, which was super helpful for framing everything onward. As well as I mainly use Smartsheets, which we basically used for everything for like tracking all the projects, doing all the sheets, reports, summaries, dashboards, roll-ups, all of it. I did a lot of work on there, but it was really great to learn all about it because it's a completely new tool to me that will definitely be helpful in the future, as well as Confluence, as I'm sure many of y'all know, where we like put our SOPs, our standard operating procedures, as well as like meeting notes, as well as UNITA, which is like a workflow management platform that we use to sync Smartsheets and Jira, which I'll also talk about later in the presentation. And so first off, I started off my internship basically by creating like a test project from scratch. So I made and tested all the different forms like risk register and the decision log and all those type of things, making sure I even like submitted stuff to those forms to make sure they're going to the right places and whatnot, and then like edited and created dashboards to summarize basically like the data or just like fake data that I would make up, as well as like checking the metadata and making sure all of it's flowing into there correctly and from the right places, and that the metadata is going into the project dashboard correctly, which was really helpful just kind of seeing how everything sort of fits together. And also like creating a fake project was really helpful with editing some of like the SOPs and things like that later. So it gave me a really good perspective on everything that they do and how they kind of set up a new project. So for the standard operating procedures, since the project management office is still fairly new, I definitely helped a lot with like reviewing, comparing, editing, and finalizing several different SOPs, just like kind of outlining some of their different procedures and processes for like intaking, planning, creating, and maintaining different projects. So this one right here is an example of one of the ones that I made over this summer, which is about the RACI matrix. That's basically defines who's responsible, accountable, consulted, and informed throughout each step of a process or a project, which is just helpful, hopefully, for those like more larger and complex projects where it can kind of, get a little convoluted with like whose role is what. So basically just outline sort of what those roles are, the definitions of each of them are, in the procedure to go about those, which the test project was very helpful since actually like making my own little project was really helpful for editing some of these and making these as well. So then next up, I also did a lot of experimenting and playing around within Smartsheets. So roll-ups, I definitely experimented with a lot, and we made one for each of the different EarthScope directorates. So this one, for example, is one of the ones that I made for the executive directorate. And it's basically just to like summarize various information about like the different projects that are going on in the directorate. So as you can see, they have like overall health, life stage of the projects, the actual projects that are going on, timelines, high priority decisions, high priority risks, all those sort of things. You can't even see the entire dashboard because it didn't all fit on here. But it's hopefully will be very useful for, especially in those like directorate meetings, to really just get like an overall view of what's kind of going on in the directorate and EarthScope wide in each of those projects, just getting like a quick little overall summarized view of those. So yeah, maybe that'll be helpful. As well as we have our resource planning, which I assisted with this, where we met with a few different like managers and stuff like that. This one is for IS, so instrumentation, where we met with the managers and kind of had them like estimate the percentage that the people on their team did for like specific projects or operational tasks, which kind of helped us identify like where teams may be overtasked, and in the next hiring cycle maybe we could put more people on that team or hire some more for that. Or if like a high priority project comes up, it will be really helpful for seeing where we can reallocate people to fit into that like high priority project that we need people on and to get it staffed. So hopefully that'll be very helpful. But obviously, as you can see, not all of the data is there yet, just because of like field season and scheduling conflicts and all of that. But I think we definitely made a lot of great progress and headway on this so far. So yeah. As well as I also worked on integrating Jira and Smartsheets using Unito, this workflow app. So basically, for projects who like, let's say they work in Jira and they have worked on it for their entirety of their project, it can be really helpful, and we want them to stay working on there because that's what they know, that's what they do well with. So they're still able to work on Jira while also we're able to pull in basically all of that information and have it on one platform, Smartsheets, of course. So it's really helpful. You basically can make like a few different rules to like restrain or allow different data to sync depending on like what you want to transfer, as well as I did have to problem solve some errors that would pop up because sometimes the fields don't always want to sync because of various reasons or permissions or whatever else. And then you can map various fields to sync them together. So for example, like if you have new tasks that are made on Jira with Unito, it will automatically flow to a sheet that we put up or that we made in Smartsheets. So hopefully that'll be very helpful. And I definitely learned a lot of things from this and a lot of troubleshooting, which was always really good and really fun to do. So I just wanted to say a quick thank you to Molly and Sarah, and honestly the entire project management team, because they were so helpful in answering any questions or anything that was going on throughout this entire process, since I was so new to project management, as well as Kelsey for putting all of this together and everyone that I talked to throughout this entire process, and EarthScope in general, just for giving me this amazing opportunity, because I really did learn so many amazing and really new things that I think will be really helpful in the future. So yeah, thank you for listening.
Thank you, Connor. We loved having you on the team.
Oh, thank you.
Great job, Connor. Great presentation. Any questions quickly for Connor? I would just say that I think we're all really excited to, as staff, to dip our toes into all of this great new stuff. So it was cool to see you get a first take and then tell us all about it. So thanks. Okay, well, thank you all so much for coming. I'm sorry that we went a little bit over. I really want to thank the mentors who guided and supported the interns this summer. We really couldn't do this program at all without you. So thank you so much. Thank you, interns, for being awesome and so productive and being interested in EarthScope and really immersing yourself in this opportunity. I hope you found it is equally as rewarding as we all did. Obviously, big thanks to Fab. They do so much behind the scenes to also make these internship programs work. So we appreciate you. SMT for being so wonderful and orienting the interns to EarthScope contracts, IT for getting computers, everything, and the rest of the internship team for all of the support. And if you have questions about the program or you're interested in getting a student, please let me know. You know where to find me. Yeah, and thank you all. Good job, everybody.